to use them here. So, but if we have to make it and delete it, isn't that like malloc-ing and free? Kind of, but not exactly. Because the mallocs and frees that happen inside of these functions are not hidden from us. This string can now be replaced behind the scenes, and we don't have to care about that. If we have a char pointer, we have to care about every single change that happens. Here, not so much. We create it once, we delete it once, but if these change something in here, change the size, reallocate, for these we don't care. So what we can do is we create the string once. You make it once in your code, you delete the string once in your code, and in between you can add as many string appends as you want, but unlike strjoin, which creates a new string every single time, or every iteration, this will not create any garbage that you have to free. Well, it does, but it takes care of deleting that one if it creates another one. If it creates yet another longer one, it also deletes that, because it has power over where this pointer points. This one will be the same. This one, we don't care. And therefore, we can add many lines of these append string. Like we always say, string append, I don't know, CSTR. And then we can run a loop basically and add hello, 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 hello. These functions will take care of the reallocation for us. Because again, if you call strjoin, you have to allocate a new one, free it, and then use the next one. Like copy it over, use it again, allocate a new one, throw the old one away. For this one, you don't need that. It does take care of that internally, and then you just delete it when you don't need it in the end. You have saved a lot of maybe malloc-ing and freeing here. See, because this disturbs you. These are string functions, and these are memory management functions. And even having them in your code is going to distract you from what's actually happening. This is important. Just to give you an overview. This one is important. This one is what's important. This one is what's important. This one is not important. And these ones are not important. Roughly 50 to 100% that you don't care about, maybe. So in the end, you only care about this line, basically. So it's pretty much of your code that's polluting or clouding your mind when you actually code. And this is bad. If you have code that you don't need to have, but that you still have in your code. Like this is part of the deeper levels of C, but they are slowly leaking up into your higher level abstractions here. And if that happens, of course, you're being distracted. And if you're distracted, bugs happen. And if bugs happen, hilarity ensues. So, in order to keep your code free of these, making this is quite important. And this doesn't only work for strings, this works for file reading. So this pointer can actually be an object. Or, I don't know, vectors for mathematics. You might use them in FDF, or where you have to draw the Mandelbrot set, fractal. That's hugely important. So therefore, objects are your friend. And if you're wondering how to implement them in C code, there are many ways. So what actually to put in here? This is very abstract again. What to put in here? And also on my GitHub repository, I have a page on that. So you can also read that later on if you want to. Not wanting to advertise more on GitHub here, it might help you out if you're wondering.
The structs or the patterns?
The structs. Sure, the structs. So let's use green. Let's say we wanted to write such a string. Again, we have this barrier in between. So what's on the left side? Let's see. What should be on the right side? I'm just going to tell you real quick because you might not be knowing about that beforehand. Usually, when you create a string struct, like the one we were just using, you add 3 elements. Struct, The first element is a char pointer to the data. This is something that has to be allocated. This is the thing that grows. This is what you usually use, that you feed into your string join. This is what you get back. This is basically the raw data. So you point to the raw data. Like here is hello. But you over allocate here. And why? You need two more variables. Int, this is what I call fill, and this is what I call alloc. And these are basically telling me where I am right now and where this buffer ends. So I over allocate right from the beginning so that I have space to fill it. If I want to add more characters, I still have space to add them so that I don't have to allocate every time I add a new character. But of course I need to know the string length, so I have them in two locations. Clear so far? Yes? Okay. Right, so let's say we want to use a make or to create a make string. Well, we don't want to expose that this is implemented as a struct. So what do we do? Type def. Now, this is basically a type def. You can also put that up here, but basically what this means, every time in your main function, if you write, I want to have a t string, str, and then str equals make string, what this actually means, it will basically replace this one with that. So what you actually have is a struct s string pointer. It's going on. But since you can't look into this if you're writing the code, this could change. You can use a void pointer. You could use an int into some kind of array of allocated objects. You don't care. That's the power of type def and structs. And now, let's get to the actual part of writing the make string. What is it going to return? Well, this is a t string, so this should also return a t string so that these match like puzzle pieces. Make string. Then I can say, well, it's a struct s string pointer, ptr. Then I can say, okay, ptr equals malloc. Yes, we need malloc sometimes. Of, but this is hidden to the user. They don't care. We don't even have to use malloc. Some cases might be different. Malloc of size of struct s string. There we go. And then of course we do the check if it's null or not. But let's say this always returns a valid pointer just for the sake of argument here, so that I don't have to write everything. We can now say, well, ptr data, and this is the only place where we are allowed to actually access these elements. Only inside of the string functions are we allowed to access the members. Outside of that, we are not. We are really not allowed. Why? Because we had that before. If we want to change the behavior of something, we don't have to tie it to these variables. We can change the entire implementation of that as long as the functions stay in there. And then they can do some kind of error handling code if you use them. Okay, ptr data equals, and of course, malloc of, let's say, 128 chars. I'm going to just abbreviate. ptr arrow fill starts out as 0, because we have no characters in there at the moment. And the last thing, ptr arrow alloc is, any ideas? Again, alloc is the size of the data that we've allocated for data. if we've allocated 128 chars, we are going to store the 128 in here. So that we know what this size actually is, because we can't count because there's no null terminator at the end. The null terminator doesn't happen here, we just save the bytes as a char version. And then, of course, in the end, return PTR. Right? Okay. Tell me if I can clear that off. Just not when I can clear that off. And then we're going to look into maybe the append char and then maybe the delete also. And then we're done.
I think I'm good.
Okay. Any questions? All right. Then let's clear it off. And wow. That's a void function. This is the thing that I left out previously. This is the magic thing that we don't know about. This is the empty box that we had. Because you can swap these out and therefore change what's in there. T-string str, and then char c, the character you want to add. Okay? And now, I don't think we have too much time anymore, so I'm going to abbreviate. So you might have to look into that on yourself. But I'm just going to write that down how it works, and then you can like make some sense out of that using your experience. Basically, what happens if we are at the end? If we don't have any more space? If we are already here and we want to insert the letter here? We have to reallocate, right? We have to, like what we did here, we have to change it to a longer version. Again, we can make strings do things. If we can think of it, we can make the string do it. We can make the string append a character, which is what we are implementing here. So why can't we tell the string how to resize this so that we have space? Like, I wish we had a way that this string could automatically grow itself. Well, if we don't